All right, so here we go. Rational exponents. What is a rational exponent? Well, you got to know what the word rational means. A rational number is a number that can be written as a fraction. All right, so what is a rational exponent? It's an exponent that can be written as a fraction. And what do they look like? Well, they look like fractions with their exponents. So I'll turn to this page, the big bright yellow one, and do you get that the square root of 16 could be written as 4, right? Just a reminder, when you have the square root symbol, that means the positive square root of it. Because you could argue that negative 4 times negative 4 would also equal 16. But when you use this symbol right here, you mean positive square root. So the answer is 4. But really what I'm getting at here is what's the question? The question could be written as 16 to the 1/2 power. How many of you knew that 1/2 power meant square root? Nobody? All right, then you learned something. One person maybe. All right. So if you want to have the 1/2 power, that means the square root. There's a little 2 here. How many of you knew that? In a square root symbol, there's actually a little 2 there. All right. One person had seen that before. All right. So in the middle school, you never talk about the square root symbol having a little 2 there because the standard form for writing this thing, you don't use it. It's sort of like it's like extra work that people don't need because almost every root you do is a square root. But now you're getting into things like this. Cube roots, right? And 4th roots and 5th roots. Yeah, but what I'm trying to say is now you'll have to understand that there's really a 2 there because that little 2 becomes the bottom of the fraction. So if I was going to do square root of 16, I'd write it like that. If I was going to do cube root of 8, I'd write it like that. You get that? All right. And if the answer to that should be 2, because 2 times 2 times 2 makes 8, this is equal to that, which is equal to 2. I want you to check that by doing this. 8 to the power of, and if you just type this on your calculator would go 8 to the power of 1 and then divide by 3. That's not what we want it to do, right? So you got to put a parenthesis right here. So I'm going to pause for a second while you get your calculator loaded up. Do 8 to the power of parentheses 1/3 parentheses. See if you don't get 2. I think you will. Okay, we double checked that, and it seems to be most kids are getting there right. Okay, then I'm going to go back to this one. If I wanted to solve this little equation, most people know that to get undo squared that you do square root. Most people would have gone like this before. And that works, but there's something that would also work now. If you understand that you can put a power to a power, what power could I put this to? To the 1/2 power. And if I do that on both sides, 2 times 1/2 makes 1. So this is x to the 1 equals, and what does that mean again? Square root of 81, sorry. And the square root of 81 is 9. But I want to warn you, I did this wrong. Only because I left off something. Can anybody think? So you're saying that the side things, yes, you're right. The square root of x squared is really absolute value of x. Remember that? I talked about this before, that that's really equal to that. Okay, if you use a variable, then you have to use absolute values. So absolute value of x is 9, and x equals plus and minus 9 is your final answer, because when it comes out the absolute values, you have both signs. Now let me explain the difference here. How come on this one I could say the answer was just 4? But on this one, I have to say the answer is plus and minus 9. Well, because on this one it means positive square root. That's what that symbol means. Do you see that symbol over here anywhere? No, you don't. And if you do square root on both sides, that positive square root thing doesn't work with the variable. So you have to do absolute values. And here's the other way to see that I'm right. That when it says plus and minus 9, if I try just using 9, yeah, it works. But negative 9 would also work. Negative 9 squared is 81, right? All right, so don't forget, when you're doing the square root on both sides, that you have to introduce the absolute values. It comes up a ton in pre-calc. I know I'm going to mark that wrong on several of your papers next year when you're taking pre-calc, because you'll forget. All right, next thing. What would this mean? We did cube roots, we did square roots, but what the heck is that thing? What do you think? You are exactly right. But there's another way to do this, but let me show you why that one works. Because that times that is 2/3. 2 times 1/3 is 2/3, right? And then 8 squared is 64, and then I got to do the cube root of 64. So there's another way. You thought of this in the first place. I bet you can think of the other way I could write it. I bet you could. 8 to the something to the something. Just do it differently than you did before. Can anybody think? Yeah, so 8 to the... Do you get that that still multiplies out to 2/3? Focus, gentlemen. Do you get that 1/3 times 2 is 2/3? So it still works. Why is this way better? Because 1/3, 8 to the 1/3 I can do in my head. What's that? 2, and then I just square it, and what's the answer? 4. Would that have been the same answer the other way? Yup. But this way is easier. Okay, so I'm going to go back to the hard way and show you what I mean. If I put 8 to the 2 to the 1/3, 8 squared is 64, and the cube root of 64 is 4. But you have to do that with this huge number, and that's kind of a pain. Let me give you an example. It's like that. Let's say I said 2 to the 3rd power. No, let's go to the 4th power. And then, no, this is not a good example. I'm going to go the 5th. And the 1/3 root of that. Make sure that's right. I was trying to make one up on the fly, but sometimes you get these where they're so difficult to do, like 2 to the 5th is 32, and do you know what the cube root of 32 is? I don't. But if I do it the other way, it'll always be easier. Put the fraction first. The problem on this one is that there's no cube root of 2, so that's not going to work out really nice. Sorry, bad example. I'm going to go back to my pre-planned examples here. All right, this one. Do you get that that would be 4 to the 1/2 to the 5th, or 4 to the 5th to the 1/2? Either way would work. I should have stuck to this example. Because this times this makes 5/2. This times this makes 5/2. Either one would work. Which do you think will be easier to do? The top one. Because the square root of 4 is 2, and 2 to the 5th is 32. Whereas this one, 4 to the 5th, I have no idea. Some huge number. And then I got to take a square root of that. So see how much more difficult that would be? But the answer is still 32. So do it this way, the way that's left here. Okay. Notice the bottom part here, that makes the fraction. The top part, that makes what power you put that to. All right, I'd like you to do this one, and then write the answer, and then zoom in on it so I can tell you if you're right or not, and hold it up like billboard style. Again, once you get your answer, no calculators. The point of this is that you should be doing this. It's the orange one. Zoom in close enough so I can see it. You are correct, correct, correct. Yep. Yes, but you haven't finished. Now just actually do it. Yes? Yes. Yes. Nope. Because the plus and minus, the implication on this kind is that you're doing just the principal square root, which is the positive kind. Save that for when there's a variable. If there would have been a variable, then you'd have been right. Good, 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 good. Not done yet. Good, good. Nope. Thank you for trying. Good, 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 good. Yes, but you're not finished yet? Yes. Any more out there? Yes. Yes. Okay. So you should have said 4 to the 1/2 to the 4th. 4 to the 1/2 is 2, 2 to the 4th is 16. And you might just say to yourself, couldn't you just put that into a 2? Yes, you could have. And then it would just been 4 squared and it would have been 16. All right. So it's good to know how to do it both ways. Because sometimes you can't reduce these, but when you can reduce them like that, you should, because it'll make it way easier. All right, moving on. This has both styles shown, again, like I was talking about. Always make it smaller before you make it bigger. See, that makes the answer smaller, and then you'll make it bigger. Okay, instead, if I made it bigger before I made it smaller, it's just a lot harder to do. Okay, focus, please, on this. Thank you. All right, moving on. You're going to need to take those off if you keep on making the noise. All right. Then, let's see, where's my new stuff? All right. If I did this, do you get that I will have a to the 1 power, which is the same as a? So that's a good reminder if you ever want to get rid of a power like 3/4 power, and you want to solve for a and get a alone, you use the reciprocal of that. So you put it to the 4/3. All right, so that's going to be used when we do some of the solving stuff in a minute here. All right, so this one, a lot of people can't make the jump from this to this. X to a power. What over what? There's a 4 and a 3. It's probably a 4 and a 3. The question is just, should the 4 be on top or should the 3 be on top? Any thoughts? I want you to take a side. It's either to the 4/3 or to the 3/4, and put it on your paper and zoom in on it. And then in a minute, I'm going to have you hold up, and I want to see how many people pick 3/4, and I want to see how many people pick 4/3. It's one or the other. All right. People that think it's to the 3/4, hold yours up. All right. People that think it's to the 4/3, hold yours up. All right. You know what the answer is? 3/4. Most of you guys are right. Okay, because look that's the root, and the root part goes in the bottom. The other part goes in the top. All right. So this one doesn't have a number out there. But what number is it really? A 2. And therefore, this is x to the 7/2. That doesn't make sense to you? Oh, it does make sense. Okay, good. All right, so this one. God, blasted answers from last hour. I thought I erased them all, but somehow they're all here. Okay. Do you get how I rewrote all of these as 2 fractions instead of just the single fraction? So 3/2, I rewrote it as to 1/2 and a 3, because that together would make 3/2. Because that helps you solve the problem. Now what's that equal to? 2 to the 3rd is 8. You getting what I'm doing here? All right. This one is to the 1/2 to the -1. That's really 3 to the -1. And do you remember what the -1 does to an answer? 1 over. So the final answer for that one? 1/3. Okay, this one. 8 to the 1/3 and then squared. What's 8 to the 1/3? And then squared? The answer's 4. Good. All right. Now you try these 3. On the seafoam green page. I'll pause while you work on them. Okay, this first one. 9 to the 1/2 to the 3rd. Make sure you're doing that right. And then 9 to the 1/2 is really 3. And 3 to the 3rd is 27. This one's got 3 parts. I hope you guys know how to do the 3 part. You go 25. Who knows what to put first? To the 1/2. I said make it smaller before you make it bigger. So that's making it smaller. Now if 25 to the 1/2 would be 5. So anyway, Then to the what? Not negative 3. That'd be putting two things at once. To the third. And then last of all, you put it to the negative 1. Because you multiply this times this times this, you'll get negative 3 over 2. And that'll tell you the right order to do it in. First, you do the square root. Then you cube that, and then you flip it at the end. You get that? So what's the square root of 25? 5. And then 5 cubed. 125. And then at the end, I do this negative 1, which makes it 1 over 125. 125th. All right. And then the last one? So you did 32 to the what? Very good. And then to the what? Good. And then that's really what? 2. And then to the fourth would be? Good. So you didn't even need a calculator, did you? Good. Okay. All right. Moving on. How do you solve equations like this? Well, you put it to the power that will make the power cancel. So I put this to the power of 3 over 2. And if I do it to the one side, I have to do it to the other. Remember how when you multiply reciprocals, they make 1? So you see how these and this will cancel, and I'll have x to the 1 power. So x is equal to, and now I have to do this little thing, 9 to the 3 halves. That's 9 to the 1 half to the third. And that's really 9 to the 1 half is 3. 3 cubed is, so x equals 27. So that's solving an equation using what you've learned. A lot of stuff to know on this. Here's another one. Look through my work. Do you see how I put it to the 2/3 power on both sides? And then I have just x here because these canceled. And 8 to the 1/3 is 2. 2 squared is 4. You getting that? All right, try this one. X to the 3 halves equals 27. Solve it. To get rid of the 3 halves so that x will be alone, I put it to the 2/3. And if you've been paying attention, you'd know that this is 27 to the 1/3 squared. And what is the cube root of 27? 3 squared is? Raise your hand if you knew the answer was 9 before I said it. Okay, good. And I think you get the idea. Here's one where I actually did it wrong the first time I tried it, because I said, oh, this is n to the 2x equals n to the 5th. Can you see what I did wrong? Yes. When you are multiplying like this, you add these powers together. And I multiplied them, and I couldn't figure out what I did wrong. 2 plus x. You add them together. And now, here's an important thing to know. Remember that base change thing? If the bases are the same, they can cancel. You remember that? So now it's just down to 2 plus x equals 5, and any third grader can do that one. All right. This one. How do you get this to be 5 to some kind of power equals 5 to the 4x? What power would I put right here? 5 to the what? What do you do with exponents when you're dividing them? Subtract them. So it should be 5 to the x minus 3. And why is that good now? Because this will cancel this. And now it's x minus 3 equals 4x. And you can solve from there. I was surprised how many kids have trouble solving this. I think it's because their first instinct is to add 3 to both sides. You're not supposed to. You got x's on both sides. Whenever they have that, you should get that fixed first. So subtract what? go like this. If you have x's on both sides, get rid of the smaller one. That's the smaller one. Get rid of it. And then I have negative 3 equals 4x minus an x is 3x, and now it's easy from there. Divide by 3 on both sides. So whenever you have variables on both sides, like this, get rid of the smaller one. All right. Last one. X to the, what power is this? 2/3 or 3/2? 2/3 equals 4, and now I just got to put it to the power of what? 3/2. And then this cancels, and then I just got to know how to do that, which we've done all hour. We break it up into two parts. 4 to the 1/2 to the 3rd, and that's how you do it. The answer would be 2 to the 3rd, which is 8. And then you can double check and actually make sure 8 works. Put it in there. 8 squared is 64. Cube root of 64 is 4. So it works. All right. The only other thing that they do is get a little more tricky, but I think you can handle these. How do you get rid of square roots on both sides? Square both sides. And then that gets rid of the root. It's as simple as that. You do not have to like put absolute values on both sides. That's if you square root both sides, not if you square both sides. And then it'd just be 2x plus 7 equals 5x minus 2, and you get rid of the smaller of the x's. You get minus 2x from both sides, and it'll make it fastest. There's other ways you could solve that, but on this one, this most common mistake I think is to say 4x squared over, and then people know that these get added together, and so they'd say 8x equals 10, but there's a mistake in there somewhere. Can you see what it is? Something about the 4, I'll give you that. Oh, you were saying you'd bring these 4s up here and then cancel them, and it would still come out to the same thing, though. So that's not it. Your way would also work, but this way works for that. There's a number wrong in here. What is it? Yes? Yes. Because remember, when this gets squared, it's the 4 gets squared and the x gets squared. So this should be a 16x squared. Isn't it easy to miss? Just have your eyes jump right over that? So again, that 4 needs to get squared, so this should be a 16x squared, and then from there, a whole bunch of stuff will cancel, and it's really easy. You got x squared on top and an x on the bottom. That leaves 1x left on the top. And then the 16 can be written as 8 times 2, and then the 8s can cancel, and it's 2x equals 10, and then x must equal 5. All right. On this one, the only hitch is that some people get confused what you're supposed to solve for, but it says right here, solve for x. That means get the x alone. So what's your first step? Times a. So it's 4x equals 16a. And then how do I get x alone? I keep asking myself that to remind me what to get alone. Don't try to get the a alone. Get the x alone. There we go. And what's 16 over 4 reduced to? 4. So x equals 4a. All right. That's all you need to know for today. So you have the rest of the time to get to work.